This is an example problem of osmotic pressure. A forensic chemist is given a powder for analysis. She dissolves 5 milligrams in 10 grams of ethylene glycol, which I'm going to abbreviate as EG. The solution has an osmotic pressure of 0.043 atmospheres. Which compound, and the temperature is 298 Kelvin. Which compound, heroin, OxyContin, or morphine, should you do a confirmation test for first? And we're asked to explain. So some additional information is that the density of the ethylene glycol is 1.11 grams per milliliter, and we have some molecular masses. For heroin, the molecular weight is 369 grams per mole. For OxyContin, the molecular weight is 315 grams per mole. And for morphine, the molecular weight is 285 grams per mole. And so the first thing that we have to remind ourselves is, what is the osmotic pressure? Well, the osmotic pressure, and we use the symbol pi, is equal to the Van't Hoff factor times the molarity of the solution in moles of solute per liter of solvent, times our good friend R, the gas constant, times the temperature in Kelvin. And I want the molarity by itself, because that's at least, I think, going to give me moles, and I have grams, so I should be able to get a molar mass. So I'll divide both sides by R times T and I. Now, this I, we expect to be 1 because we don't think any of these are salts. And so my molarity is going to be pi divided by I, which is 1, times the gas constant times the temperature. And now I can put my values in: 0.043 atmospheres. I need R in atmospheres, so the atmospheres will cancel. So I need 0.08206 liter atmospheres per mole Kelvin. My temperature is 298 Kelvin. Let's see, my atmospheres cancel, my Kelvin cancel, and the mole, the denominator of a denominator, comes up top. So I'm going to have moles per liter, which is good because I'm looking for a concentration. And that number is 1.76 times 10 raised to the power -3 moles. Now this is the powder divided by liters of the solvent or solution, actually. So I'm going to assume that this is just the volume of the ethylene glycol. Now I can find the volume of the ethylene glycol because I have its density. And so I started with 10.0 grams of ethylene glycol. And I know that its density for every 1 milliliter is 1.11 grams. And I inverted this so that I can actually cancel the grams and get a volume. But I need liters, but I know that there's 1,000 milliliters in a liter. And so the volume here is 9.01 times 10 raised to the -3 liters of ethylene glycol. So now if I multiply the volume of ethylene glycol by the molarity, I should get moles of my powder, which is good because I have mass. And so I need 1.76 times 10 raised to the negative 3 moles of powder divided by liters of ethylene glycol times 9.01 times 10 raised to the power negative 3 liters of ethylene glycol. And I find out that I have 1.58 times 10 to the minus 5 moles of the powder. And I have my mass, and I have to remember that milli means times 10 raised to the power negative 3 grams of the powder. I'm going to divide by the total number of moles of the powder, 1.58 times 10 raised to the power negative 5. And so I find out that the molar mass of my powder is 316 grams per mole. And now I have to come back and say, oh, that's closest to the OxyContin. It's lower than the heroin, higher than the morphine. So the next test should be some sort of confirmation test for OxyContin.